Okay. We are moving on to section 2, and that is arithmetic and geometric sequences. So we saw yesterday that sequences are just any pattern of numbers. And today we're going to look at two special kinds. And what's nice about these two special kinds is that we can get formulas to find their general terms and everything. So let's start off with an arithmetic sequence. It can be defined recursively or explicitly. If it's defined recursively, it's a sequence. This is first term, second term, third term, A1, A2, A3, dot, 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 and it keeps on going. Now it's arithmetic if there is a constant D, for which to get the nth term, you take the term right before it and you keep on adding this D to it for n greater than 1. Defined explicitly, this is the formula you're going to want to memorize. The nth term is equal to the first term plus n minus 1 times that common difference. The common difference is what you add to each term to get to the next one. You can find the common difference by taking the term on the right and subtracting from it the term on the left. That's what an minus 1 means. All right, so let's determine if this sequence is arithmetic, and if it is, then let's name the common difference. So I'm looking at these guys and I go, all right, 20 to 12 to 4 to, okay, so what am I doing? To 20, I would add a negative 8. 12, add a negative 8. 4, add a negative 8. Negative 4, add a negative 8. For it to be an arithmetic sequence, it means that the same differences between each of the terms, but all of them were adding a negative 8. And so this is a yes, it is arithmetic, and your common difference is a negative 8. Here we got decimals. All right, 9.3 plus what? 0.6 would give you 9.9 plus 0.6 works. Plus 0.6, yep, plus 0.6. Nice. All right, your common difference is 0.6. Create your own arithmetic sequence with a common difference of negative 1.5. I'll let you pause the video for just a second and come up with one real quick. Pause it. Hopefully you paused. What would be the easiest one? I don't know. You could do, if you started with a 1, then it would be a negative. Oh, I don't like that. Let's do something easier. How about, we could have done that, it doesn't matter, but how about a 10? Adding a negative 1.5 would give you 8.5. Adding a negative 1.5 would give you 7.0. Adding a negative 1.5 would give you 5.5. Now, you could have done, you just start off with some number, add, because it's arithmetic, you're adding this negative 1.5 to each term to get to the next guy. Easy peasy lemon squeezy, right? All right, let's find the 102nd term of this sequence. 5, 13, 21, 29. All right, well, that one, we're going to use this explicit formula, yeah, where n will be your 102. A1 is the first term, so that's 5. That's what I say first, yep. What's the common difference? To go from 5 to 13, add 8. Plus 8 gives you 21. Plus 8 gives you 29. So your common difference is 8. We want to know the 102nd term, so 102 is your n. So in this guy, I'm going to put a sub 102. It's the first term, 5, plus 102 is your n, minus 1, and then times the common difference, which will give you 813. So explicit formula is super friendly, right? Especially when they're asking you to find a specific term. Keep in mind the graph of a sequence is just a set of points, and you don't connect those points, right? Usually we start when plugging in an n is 1. Sometimes you'll see n equals 0 as your first term. We don't ever plug in a negative into n, but it's all of these individual points. You don't draw the line through them. Versus a function that's continuous would be the line going through everything. But a sequence is just the set of each distinct value or point. So if we know two terms of a sequence, we can definitely find a formula. In an arithmetic sequence, let's say that the a sub 5, that means the fifth term is 24. A sub 9 means the ninth term is 40. We want to find the explicit formula. So let's write what we know. I know the fifth term is 24. So that means when n is 5, right, so 24 over here, it's equal to the first term plus n was 5. 5 minus 1 times the common difference. I know the ninth term is 40. So I'll plug 40 into the left-hand side. It's equal to a sub 1 plus plugging a 9 into n now. So simplifying these two guys, I get, this one would be an a1 plus 4 times d is equal to 24. This one would be a1 plus 8 times d is equal to 40. And if you want to solve this system, you could just subtract the second equation from the first. And when you do, it changes all the signs. The a1's cancel. 4d minus 8d is negative 4d. 24 minus 40 will give you negative 16. Dividing both sides by negative 4 will give you d is positive 4. All right, so now that I know d, plug it into either one of these to solve for a1. I chose this guy. I chose 24 is equal to a1 plus 4 times 4. So that's where I got 16. So a1 plus 4 times 4 gives you the 24. Subtracting 16 gives you a1 equals 8. Plug that into the nth term is equal to the first term, that was 8, plus n minus 1 times the common difference. The d we found was 4. And then you're going to definitely simplify this. Distribute that 4 into the n and into the negative 1, and you'll get a 4n minus 4, but plus 8 gives you that guy right there. So the nth term is 4 plus 4n. And if you check, a5, that's if you plug a 5 into n. 5 times 4 is 20 plus 4. Whoop, whoop. Plug a 9 into n. 9 times 4 is 36 plus 4, 40. You got it. Arithmetic means, what does that mean? So if a1, a2, all of these guys are terms of a sequence, right? Then all of the guys, so not including a1 and not including ak, we call all of these middle guys the arithmetic means between a1 and ak. So all of the middle terms are called the arithmetic means between this guy if it's an arithmetic sequence. So let's find 3 arithmetic means between 9 and 29. All right, so I'm going to list the two numbers they gave me, 9. If I'm finding 3 arithmetic means, I'm going to draw 3 blanks. Now, I show you a very streamlined way of doing this, which is totally fine, but it means you have to memorize something else. So I'm going to also show you first what I would do. This is your first term, second term, third term, fourth term, fifth term, right? Well, that means that the fifth term is equal to it's the first term plus 5 minus 1 differences. Yeah, but the fifth term was 29 and 9 was the first term. And so subtracting 9 and then dividing by 4. Your common difference is 5. And so you just add 5 to get 14, add 5 to get 19, add 5 to get 24. When I add 5, do I get 29? Yes, I do. So those will be my answers. All right, so I don't like memorizing, so I don't memorize this next way I show you to do it, but it is a streamlined version, and I have a lot of students, I'll show them this, and they'll go, but Mrs. Bright, I just subtracted 29 and 9, and then I divided by 4. Yeah, so did I, right? That is I just did it with a formula, but I did the same thing. I subtracted 9 from 29 and I divided it by 4. All right, so here's the streamlined. And if you'd rather just memorize this, by all means, you do that. Come on, why won't you let me change? streamlined way. You find the difference by doing 29 minus 9 divided by 4. The last minus the first, and 4 is the number of commas you've got. Yeah. And so you get D is 20 divided by 4, so 5. And there you go. So just a faster way to do it. It's the same thing I just did. But if you want to memorize that it's last minus first divided by number of commas, right? 1, 2, 3, 4 commas. Then, or it's 1, 2, 3, 4 differences. Those commas are representing how much difference is in between. That works too. Okay, so that's arithmetic. Arithmetic meaning I'm adding a number to get to the next one. If I want to do geometric sequence, we can define it either recursively or explicitly. Geometric, defined recursively, is a sequence, A1, A2, A3, that's first term, second term, third term, dot, dot, dot. If there is a constant R for which the nth term is the term right before it times R. So geometric means you're multiplying the same number to get to the next one. Arithmetic, you're adding. Think about when you did arithmetic back in elementary school. You were added, right, or subtracted. That's arithmetic. Geometric, yeah, I don't know how I can explain to you that it's a times, but it's times, right? We're multiplying the same number to get to the next guy. It also can be defined explicitly. Definitely memorize this formula. This is the nth term is equal to the first term times your common ratio, R, raised to the power of n minus 1, where R is the common ratio. And you can get that common ratio by dividing consecutive terms. You take the one on the right and divide it by the one on the left. So that's common ratio. Definitely memorize this guy for sure. You'll also need to know how to write it recursively, but I feel like that's more, I know the wording is weird, but okay. Okay, pause it for a minute. Create your own geometric sequence with a common ratio of R equals -2. Write your own. Pause it and do your own real quick. All right, let's see. What do you want to start with? Easy one would be a 1 times -2 times -2 times -2 times -2. There you go. There's 1. You didn't have to do that one. You could have started with a, how about a 5? -10, +20, -40, +80, whatever, doesn't matter. Okay, so hopefully you created your own. All right, let's find an explicit formula for the geometric series of 4, 20, 100, 500, and then use it to find the nth term. All right, so your first term is 4. What is your common ratio? They tell it's a geometric. 4 times what will give you 20? 5. Is 20 times 5 100? And is 100 times 5 500? Yep. So your R, the other way to do it, because that was pretty easy. Sometimes you'll find ones where they're not so simple to tell. You just take the number on the right, you divide consecutive terms. The one on the right divided by the one on the left. So 20 divided by 4. It also would have worked if you went 100 divided by 20. It also would have worked if you had done 500 divided by 100. Either way, you get 5. And the formula for a geometric sequence is the nth term is equal to the first term, that was 4, times the common ratio, 5, raised to the power of n minus 1. So there's your general term. That's an explicit formula. Now to use it to find the nth term, that means your nth term, ninth term. To find the ninth term, you're plugging 9 into n. Now, make sure, remember, order of operations says you do the exponent before you multiply. So you go to the exponent, 9 minus 1 will give you 8, so it's 4. Okay, I just jumped to it. it's 4 times 5 to the 8th power. You want to do 5 to the 8th power first, and then times 4. If you put it straight up in your calculator will do the exponent before it multiplies. But don't you dare go, oh, this is 20 to the 8th power. No, it's not. No way, Jose. It's exponents first. Oops, sorry about that. All right, so the answer, when you put that in your calculator, I might as well write. You should probably write that down. This is not equal to 20 to the 8th power. Exponents before multiplication. Right? So don't multiply the 4 times the 5 first. It will be wrong. Very wrong. All right. So same thing with arithmetic means, but now it's geometric means. If this is some sequence, A1 to AK, then the guys in the middle, A2 to the AK minus 1, these guys in the middle here are what we call geometric means between the first term and the last term. If I say locate 3 geometric means between 4 and 324, you're going to write the first number. You're finding 3 geometric means. So I'm going to draw 3 blanks. 1, 2, 3 for the 3 means in between, and then the 324. I'm going to show you the streamlined way of doing it again, but I hate memorizing. So this is the first term, second term, third term, fourth term, fifth term. Yeah. And the geometric sequence is found by the nth term is equal to the first term times r to the n minus 1 power. So that means that the fifth term is equal to the first term times r to the 5 minus 1. Well, the fifth term was 324, and the first term was 4, and that's times r to the 4th. Dividing by 4 will give you 81 is equal to r to the 4th. Taking the 4th root will give you plus or minus, because you're taking the even root, 4th root, right, of 81, which is 3. So your r is plus or minus rad 3. For geometric means, that might happen, especially if you're taking an even root of something, it's plus or minus. So that means we have 2 different answers. We have when r is positive 3. So I'll usually write when r is positive 3, I would have a 4 and then a 12, 30. Oh, shoot. 12 times 3 would be 36. Times 3 is 108. Times 3 gives me 324. And when r is negative 3, it just changes the signs on every other one. There we go. So your geometric means are the ones in the middle. You have 2 different answers. So this is an or. Now, either one of those are the geometric, well, they're both geometric means. Yeah. Okay, so that's how I do it, because I don't like memorizing, but I'm going to show you the streamlined way, which here's what we did, right? We took the last term, I divided it by the first term, last divided by first, and then I took the 4th root, right? And that's how many commas? 1, 2, 3, 4 commas. So that's the streamlined way. Erase and there you go. Number of commas is the root, and you're taking that root of the last divided by the first. So 324 divided by 4, 4th root of 81 is plus or minus 3. Positives or the negatives. There's your answer. So either way you want to do it, I don't care. If we are asking for a single geometric mean, just one, it's called the geometric mean between 2 numbers. There's only one number in between. It's just going to be plus or minus the square root of a times b. And you need to make sure your signs are the same. So you'll only be given two numbers. If they're both negative, your geometric mean is negative. If they're both positive, your geometric mean is positive. So let's find, oh, here's another way that it says it. Instead of the geometric mean, sometimes they'll call it the mean proportional. Means the same thing. Geometric mean and mean proportional means the same thing. All right, so find the mean proportional if it exists between negative 42 and negative 378. It's equal to plus or minus the square root of multiplying these two guys together, which you'll end up with a plus or minus 126. Do I give both? Do I give one? The signs must be the same. Since this was negative and this was negative, your answer is negative 126. Match the signs that are given to you. Only with the geometric mean. Up here, the signs matched, but yet we had two different answers. When you only have just one, we just match it. It's standard. How about the geometric mean, or the mean proportional, means the same thing, of 1 and negative 16? 1 and negative 16. Well, first of all, if you try to plug it in, you're taking the square root of a negative. That's imaginary. Not only that, but no matter what you multiply, like it would be a 4, right? So 1 times positive 4, but then 4 times 4 would give you positive 16, not negative 16. All right, if you try negative 4, 1 times negative 4 is negative 4, but then when you multiply times negative 4, you get a positive 16. So if the signs aren't the same, it doesn't exist. You can't find one number in between there to make that happen. All right, that's it. Here's your homework. It says there are several word problems in the homework. Just make a sequence and then apply the rules. Don't skip them. They're not hard. Just make a sequence out of what they gave you. All right. You guys, nope, don't want them. You guys have a fantabulous day, and come see me in office hours if you need help or have questions or just want to say hi. A lot of you I haven't seen yet. I'm sad. Come see me, okay? Bye.